It's that time of week again, Sunday, 6 p.m., and welcome to Steve's Place. We have a pretty good show lined up tonight. You're going to learn a whole new concept about uh, electronic generators and solid state batteries that can serve as a solid state battery. Anyway, in the meantime, first though, I want to remind everybody about our upcoming conference in Albuquerque. Um, August 7th to 11th. Mark your calendars. Those who sign up right now can get 30% off. If you sign up two or more, you get an additional 5%. So please give me a call. Teens are free. Don't count towards the discount though. But teens are free. And so it'll be a great time for family. Every night we have a social interaction there with food and everything. And you can sit down and talk to the speakers of that. And get to know them and can make a better access about what they say. And anyway, if you decide to come, give me a call 520-463-1994 during the week, or just go to www.teslatech.info and you can sign up online. Um, anyway, I'm looking forward to you all getting ready to sign up. The hotel rooms will probably be about mid 80s, but that will include a free breakfast. They're a bargain. Normally, these rooms run for $180. If you walked in off the street during a conference, and that's what you'd be paying, $180 a night. So take advantage of that. You're saving $100 a night just by signing up. Anyway, give me a call, 520-463-1994. And then, good news, on our YouTube channel, we are over 15,000 a day. So 15,000 subscribers. Uh, and our subscriptions are free, so I encourage everyone to go up there and become a subscriber. Let us know you like us. When you're up there and you're watching the show, don't forget to give us the old thumbs up, because those thumbs up is what counts towards YouTube recommending us to other audiences and that. The more thumbs up we have, the more we appear on the throughout the system there. So the thumbs up are very important. And I'd like people to get used to going to teslatech.info, the homepage, and check out the Tesla Tech channel. You click on that, and you pick out the 2023 conference. We already have we're starting to put some videos up there. To watch them, though, you have to be a member. Members are $9.99 a month. It's a bargain, considering like a single video costs like $20, for the conference videos. So each. So go ahead, sign up, $9.99 a month, unlimited viewing. We have over 1,200 videos that are member only online right now. We have a couple hundred that are subscribers, which are free. But by becoming a member and joining the YouTube channel, you help us keep these things going and getting more material. Okay, and without further ado, I'd like to introduce West Plischke, and he's going to tell us about the Plischke Generator. And tell us a little bit about yourself, West.
Hi, Steve. Thank you for having me tonight. Appreciate you. Well, I have a background in electrical engineering, audio engineering, music production, and designing controlled environment agricultural systems in legal regulated state environments. So, which leads me to what I'm presenting here tonight. This is the Infinite-Range Nucleus ARC, which is a system, a solid-state unified power system designed to convert the potential energy stored within permanent magnets into electricity, the first of its kind. Configured to increase the rate of change of magnetic flux within the circuit by interacting with the static magnetic field provided by the permanent magnets. It's an array of electromagnets and permanent magnets that interact in concert to enhance the overall magnetic flux within the circuit as the electromagnets oscillate intensity. The unified system design recovers the input power to the electromagnets and the additional magnetic flux provided by their interactions with the permanent magnets by means of electromagnetic induction, adding the EMF produced by their interactions, effectively recovering the input EMF, and collectively producing more electricity than what is required for input power. It's a solid state, fuel-free, fully autonomous energy source that doesn't rely on a separate power source or battery to function. This system sends a fraction of the power it produces back to itself as input power. This device demonstrates excess energy generation while remaining consistent with the fundamental principles of physics, producing more output than the energy it requires to operate. The surplus of energy to draw from is a result of the energy contained within the system itself. Energy has not been created. The potential energy stored within the permanent magnets is accessed, adding energy to the system. This is not to be misunderstood as a hypothetical perpetual motion machine that is supposed to operate indefinitely without input power. On the contrary, this system requires input power. Power input and the additional magnetic flux provided by the interactions with the permanent magnets is recovered by the system, and a fraction of the energy produced is looped back to the system as power input, enabling a self-contained system, the first of its kind, a unified, fully autonomous power system. Internal energy is the sum of a system's kinetic and potential energies at the molecular level, the first law of thermodynamics. It seems that some people have misunderstood the laws of thermodynamics. This is an active, fuel-free, zero-emission power system that eliminates the need for heavy batteries, charging time, and fuel, providing continuous energy for infinite range travel with greatly improved power-to-weight ratio and zero-emission operation, providing high power density above all current forms of power generation at 200 kilowatt hours per cubic meter. This is more than nuclear as well. Generating zero-emission electricity for the residential, commercial, and industrial power sectors as an infinite range travel for electric vehicles. Each system has an integrated kilowatt hour meter that uploads power usage data. The client is billed per kilowatt hour. The Infinite-Range Nucleus ARC obsoletes fossil fuel and nuclear-driven power plants, providing a 100% reduction in carbon emissions with power densities above and beyond all present forms of power generation. The Infinite-Range Nucleus ARC will be rapidly adopted as the logical power upgrade to pre-existing power plants, improving profit margins, increasing power density, and eliminating carbon emissions by 100%. Supplying off-grid localized power generation for future city and urban developments in remote regions, a mobile fuel-free power source solution that enables these operations to function efficiently without relying on expensive fuel deliveries or grid connections. Similar to how local power companies provide power meters, the Infinite-Range Nucleus ARC will be integrated into each residence and monetized independently, each with their own integrated cellular network and kilowatt-hour meter for real-time billing data. Localized power generation provides for rapid urban development, eliminating the cost and time associated with grid connections to new areas, providing clean, reliable, and affordable power to remote and underserved regions, improving living standards, supporting healthcare, education, and economic development. Capable of operating margins greater than 90%, the Infinite-Range Nucleus ARC has great potential for net annual revenue when implemented globally. With minimal operating expenses and continuous power output, the Infinite-Range Nucleus ARC eliminates the need for fuel or the sun to operate, providing continuous electricity and high power densities. Some of the applications include infinite range automobiles, no charging required, zero emission replacement for nuclear, coal, and gas power plants, infinite range zero emission electric air travel, remote mining and excavation, domestic and interplanetary, emergency and disaster response vehicles for remote locations, military applications for remote power stations and infinite range operations, fuel-free ocean exploration, submersibles and container ships, infinite orbit satellites, and infinite range all-electric space travel. Battery-free, fully autonomous AI robotics with infinite range. Inspired by nature, the Infinite-Range Nucleus ARC is in a design class of its own. Of truly infinite proportion, the Fractal Infinite Expansion System exhibits self-similarity with identical components at various scales as found at the atomic scale throughout nature. This provides for resonant coupling via geometric alignment and phase coherence of each component at all scales, compounding power density with each expansion. I'll go into that a bit further as far as the fractal nature of the system, which is new to itself. This will provide for the first mobile utility company. Each infinite range nucleus arc replaces EV batteries and provides high current power on demand, providing infinite range travel and performance improvements with increased power to weight ratio. Each unit has a built-in kilowatt-hour meter and cellular network that upload power usage information and system diagnostics for real-time billing and data feedback. As a mobile utility provider, the Infinite Range Nucleus ARC will capture a measurable portion of the EV power sector. Stage 1 systems, in conjunction with a greatly reduced battery size, will provide for infinite range options for economy vehicles. Stage 2 systems act as a complete battery replacement for direct, high-current, hyper-performance vehicles. Stage 1 systems produce less power, so they would work in conjunction with electric vehicles that already have batteries as an onboard charging system, whereas a stage 2 system can replace the battery system completely and provide enough high current power to the accelerating and any given point, however much power would be needed, it's then available. The Infinite Range Nucleus ARC is an active, fuel-free, zero-emission power system that eliminates the need for heavy batteries, charging time, and fuel, providing continuous energy for infinite range travel and greatly improved power-to-weight ratio. Let's see. I'm going to get more into why it works instead of focusing on the applications. So let's see. Now, I've color-coded the components to make the conversation easy so we can identify the different components and what they do. But really what you see here, the secondary coils being black and blue, those are copper coils. So they would be copper coil at the point of manufacture. They'd be copper in color. Now, what we have here, we have an array of electromagnets in a circular radial positioning. We have secondary coils, and then we have permanent magnets. So the permanent magnets are in yellow and black. And the reason that I have them in yellow and black, the black is to show the South Pole and the yellow is the North Pole. With the electromagnets, the red and the black always signifies the South Pole. And it's important to show the magnetic interactions and the associated poles, so you can see that there's magnetic coupling occurring within the system. So what this does is, first of all, the radial positioning of the permanent magnets here, they create an attractive field, and the South Pole draws into the North Pole of the neighboring magnets. So this is creating a circular magnetic ring, so to speak. Now, with the geometry associated here and having the electromagnet essentially in this cradle in between between the actual permanent magnets in a very powerful magnetic field here, this positioning is essential at magnifying and combining the magnetic flux between the electromagnets and the permanent magnets. So when the electromagnets are powered, and they're powered with oscillating sinusoidal direct current, so they're always in an attraction phase. They're oscillating their magnetic flux, their magnetic field intensity, in a sine wave format. Now, as they do that, they're always in an attraction phase. And when they're attracting to the permanent magnets here, magnetic coupling occurs, also known as magnetic stacking. Now, the magnetic flux of the permanent magnets and the electromagnetics are equal to each other. And they, when combined, equal the maximum magnetic flux that can be induced in the secondary coil up here. So these magnets are sized specifically to the magnetic flux that the electromagnets produce. So this is equal magnetic flux from the permanent magnets to the electromagnets. Now, to understand the operation here, what we already have in electrical engineering that's used, throughout everything, we have step up and step down transformers that basically have a primary coil and a secondary coil. And you can look at the electromagnets as the primary coil. So to just look at these two functions alone and realize that through electromagnetic induction, the majority of the energy produced in the electromagnet is being induced in the secondary coil. And we already know that efficiency ratings from 95 to 99% can occur as far as the transfer of energy for a step up or a step down transformer. Now, this is sort of an enhanced, you could call it a step up transformer. And the circular and radial configuration actually improves the efficiency of a transformer in itself. And the reason being is that there is resonant coupling that's occurring here. Because each of the electromagnets are powered with the same phase, they're in phase coherence. So what happens here is they magnetically couple to each other and the impedance canceling occurs. So they're operating highly efficiently, and they also they terminate, one terminates into the next, similar to how the permanent magnets terminate into the neighboring magnet. They're all in attraction phase. The same thing occurs with the secondary coils. So we're minimizing loss in the circular radial configuration of the three main components. So with the magnetic coupling and the magnetic stacking of the permanent magnets and the electromagnets, what happens is the magnetic flux are combined, they add. And this geometry helps that process to be very, very efficient. You can see that we're in a cradle here. So we're already in the magnetic field of the permanent magnets. So once the electromagnets are activated, it's highly efficient at combining the magnetic flux from the permanent magnets and the electromagnets, which now brings the power from the permanent magnets to the surface area of the secondary coil up here. So what this does is effectively integrates the static field of the permanent magnets into the electromagnets, which then brings that to the surface of the secondary coils. So the magnetic flux is effectively enhanced with the oscillation of the electromagnets and the magnetic coupling that occurs with the permanent magnets. Now, the silver frame in here is a non-magnetic, non-electrically conductive, it's called nylon G, which is a nylon material that's glass infused. So it has a very high melting temperature, which this entire system, well, almost the entire system, is designed for 3D printing. And the program that I use, it is directly compatible with 3D printing. So everything except this outer soft iron ring, or mu metal is really what it's going to be, but those are both forms of soft iron, which have high magnetic permeability. And this the magnetic field provided by the permanent magnets, coupled with the outer soft iron ring. The soft iron ring aligns its magnetic domains with the permanent magnets, creating an attractive force from the permanent magnets to the outer ring here. So this is extending the magnetic field and controlling the magnetic field of the permanent magnets and looping it back to the system. So let's see, go down to here. Now, to understand this and compartmentalize this a little bit further, the system is essentially 8 slices of the same thing occurring simultaneously. So this is a little easier to understand here. We have our secondary coil, we have the primary coil electromagnet, and then we have the permanent magnet. So these are all doing the same thing simultaneously. And because of that, they attract to themselves, creating magnetic coupling between all of the 8 slices and 3 components. What's interesting too is that the surface area here where that it's coming in contact, the electromagnet with the permanent magnets, and then the surface area here with the electromagnet coming in contact with the secondary coil is actually the identical amount of surface area. This electromagnet acts as a magnetic channel between the permanent magnets and the secondary coil. Now, another design aspect that is unique to this system is the fractal infinite expansion system. So this smaller units are designed and configured to operate inside of larger units, enhancing the overall magnetic flux of the system and the entire system magnetically coupling for system-wide phase coherence and resonant coupling. This is 49 stage 1 units stacked to go inside of 7 stage 2 units that then go inside of a single stage 3 unit. Now, what this does and why this is important for efficiency purposes, but also for operational purposes. The combined power of the 49 stage 1 units is what the stage 2 unit requires as input power. Now, the output power of the stage 2 unit is what the stage 3 system requires as input power. The stage 3 system, once you get up to this size, just to give you an idea of the sizing here, the stage 1 units are 3.6 inches in diameter and 0.66 inches thick, okay? Whereas stage 2 system is about 24 inches in diameter, and then a stage 3 system is actually 15 feet in diameter. So stage 1, as previously mentioned, would be for smaller applications or lower power applications. And this is a dynamic system that these can be used as structural rigidity as well. So this can be built into the fuselage of a building or a craft that not only provides structural rigidity, but it also provides active power generation. Now, because the small units provide input power to the stage 2 systems that then provide input power to the stage 3 systems, and the stage 3 system produces over 1 megawatt of available power to draw from. So configuring the system this way is advantageous because in order to send power back to the system itself, there's a pulse width modulator. And by running the pulse width modulator on the stage 1 units, this stack of stage 1 units, it consumes about 1,500 watts as input power for the total system to produce over 1 megawatt of energy. So by having the integration of the pulse width modulator that's only having to deal with such a small amount of energy to actually dictate the overall power generation, it provides efficiencies across the board because, you know, with every component added to the system, there are efficiency losses. And the higher the power that has to be controlled, the more potential for energy loss is associated. So it magnifies the efficiency. The bigger we go, the more efficient they actually become because of that rule. Now, as I mentioned before, this is designed to, and I'm ready to 3D print right now. And this is what it would look like without my color coding happening. So we have our copper coil electromagnets. We have our copper coil secondary magnets. Secondary coils. And then we have the non-conductive nylon G frame. Now, this is all printed as a single piece. And what that does is provide extreme structural rigidity, but it also, this nylon G, it is a dielectric insulator as well. So although this system does fit into a sleeve that's slightly larger than the system itself, which provides for mineral oil cooling, it is insulated with this solid material as well. And that's in between each one of these coil layers to provide extreme rigidity. Let's see. We have integrated channels in here for the liquid cooling system to effectively cool the system. Now, the cooling is important for more than one reason. First of all, when you're dealing with current is if you heat something up, the current goes down. So maintaining temperature is critical for the power of the system to stay consistent. And this also applies with the permanent magnets. If the permanent magnets get hot, then they don't produce as strong as of a magnetic field, similar to how the copper reduces its magnetic field as well. So temperature control is crucial for basic system operation. Now, it also allows us to drive the system much harder with the cooling system in place, and the dielectric mineral oil cooling system also allows for very high voltage operation. So this provides for high voltage DC operation for intercontinental power transmission and efficient operation under heavy load. Let's see. Now to go into some detail on the actual coil design. I call this the macroatomic coil. So my design here is to utilize any given shape and area as a complete use for magnetic flux for the highest potential power density within a given space. Now, a lot of electromagnets they include a soft iron core. Now, that's just sort of an easy way to wrap wire around and generate a magnetic field, but it's not the most efficient way. And the reason being is that there's limitations in the saturation of the magnetic core of the material being used. So with this, we have input current here, and this is a bifilar double helix coil. So these are like, each one of these layers are magnetically attracting to each other. And the current flows down this way and then loops back up into the second coil column here. Each black space in between this, it shows you the next coil columns. So these are an array of multiple coil columns that are wired in series to utilize the entire given space and maximize the magnetic flux potential within that given space. So we have, this also is configured to match the poles of the permanent magnets as well. And the same applies to the secondary coils. And here is showing how the permanent magnets attract to the next. North poles attract to the south poles, and this creates a magnetic ring here, which is a highly efficient application of the static magnetic field. This way we control and contain the magnetic field, and then we provide a, you can call this like a cradle of life right here, where the electromagnet sits into. This is highly efficient, highly powerful magnetic interactions. And this is showing the soft iron outer ring. We have the nylon G non-magnetic material, non-electrically conductive, and we have the permanent magnets placed in that. Then the electromagnets go into this cradle, and then the secondary coils over here, capturing all of the magnetic interactions that happen within. Helical wave macroatomic secondary coil. The secondary coils are configured to induce the flux generated by the electromagnets and their interactions with the permanent magnets. Lenz's law states that when there is a change in magnetic flux within a coil, the EMF induced in a nearby coil produces a magnetic field opposing the change in magnetic flux. The EMF induced in the secondary coils form an attractive force with the electromagnets. The coil configuration maximizes flux linkage for efficient energy transfer via magnetic coupling, similar to how a step-up transformer transfers energy by means of electromagnetic induction. There are two processes that occur simultaneously as the electromagnets oscillate their intensity. The first process is the effective recovery of the input energy to the electromagnets. Second process is the increase in induced EMF produced by the interactions of the electromagnets and permanent magnets. The radial configuration of the components provide powerful magnetic interactions with permanent magnets and electromagnets as the electromagnets oscillate their intensity. As the electromagnets oscillate their intensity, they react with the permanent magnets in attraction configuration, magnetically coupling and combining magnetic flux. This process increases the rate of change within the circuit, effectively harnessing the energy within the permanent magnets and directing that energy into a magnetic flux within the secondary coil. The secondary coils induce the overall EMF produced by the electromagnets and their interactions with the permanent magnets, generating more electricity in the secondary coils than what is required to operate the electromagnets. Now, as I was saying earlier, the power that I drive the electromagnet and the power that the permanent magnets emit are equal to each other. And their combined EMF is the maximum EMF that the secondary coil can produce. So the secondary coil dictates the power that we drive the electromagnet at, and also the power that the permanent magnets are built to provide, right? Because those are custom permanent magnets, and we tell the manufacturer exactly what we need the magnetic field strength to be. This is just a visual showing what's attracting to what, and showing the full system-wide magnetic coupling. Now, regarding resonance, resonance occurs with the electromagnets and secondary coils due to the matching geometry in single-phase sinusoidal HVDC current, ensuring phase coherence. As a result of the naturally occurring resonance amongst the radially positioned repeating components, Resonance and impedance matching occurs, which cancels impedance and increases the amplitude of the oscillations, a result of a unified system. The system can be divided into 8 slices, each slice working independently while in perfect geometric alignment. The north poles of one slice attract to the south poles of the neighboring slice. The radial positioning ensures that the edges of every slice terminate into the next, forming a magnetically coupled ring, which strengthens the magnetic field of each slice in constructive resonance, maximizing efficiency. Now, why I love the inverse square law and all of the energy that it governs, from light to sound to electromagnetism. The inverse square law in physics describes how a physical quantity or strength diminishes with a distance from a point source. So optimizing the proximity of the coil layers and interactive components enhances efficiency by maximizing the impact of this law. The closer the distance, the stronger the interaction. The nonlinear effects of electromagnetism have been taken into account and harnessed for this design process. Magnetic stacking and hybrid electromagnet effect. The design and configuration of the electromagnets and permanent magnets provide a magnetic stacking and hybrid electromagnet effect that magnetically couple and increase the overall magnetic flux density and the EMF induced in the secondary coils. The electromagnetics combine with and extend the permanent magnet's magnetic flux to the secondary coils as the HVDC power oscillates. Macroatomic dynamic structure. The design structure resembles how the magnetic moments align within the magnetic domains within permanent magnets at a microscopic scale. The magnetic properties of a permanent magnet arise from the alignment of microscopic magnetic domains within the material. A magnetic domain is a region within a material where the atomic magnetic moments of atoms or ions are aligned in the same direction, resulting in a net magnetic dipole moment for that region. It is a localized area where the magnetic moments of individual atoms or atomic groups act cooperatively, producing a measurable macroscopic magnetic field. Each coil can be looked at as a magnetic dipole. Each coil turn behaves as a magnetic moment. The magnetic moments within the coil align their magnetic domains, and their aligned magnetic domains combine their magnetic flux, collectively generating a macroscopic magnetic field, a result of the geometric alignment of the parallel unidirectional current flow provided by the macroatomic coil structure. The helical wave macroatomic coil design embodies the atomic structure of parallel magnetic domains as found within permanent magnets at an atomic scale, providing a flux path for the current to align their magnetic moments in cooperative wave coherence, resulting in high magnetic flux density. This structure allows for both horizontal and vertical flux, axis flux, and utilizes the area typically taken by a magnetic core material and places it with active power generation. This means that the maximum flux density within a given area has a higher potential and is not limited by the typical iron core electromagnets that are limited by their saturation point. Once the soft iron core reaches its saturation point, it cannot be further magnetized. The magnetic flux density is proportional to the arrangement of parallel fields and the current running through them. Each turn in a coil is an additional parallel field and can be looked at as a microscopic magnetic domain at a macroscopic scale. Fractal expansion. The geometric relationship of the infinite-range nucleus arc and each of its components are found throughout nature at the atomic scale, exhibiting fractal self-similarity at varying scales. Designed with constructive interference in mind, each component's unique shape geometrically corresponds to one another to form the overall system, promoting constructive interference. The inner units combine to form the inner core of the scaled expansion unit. The components of the inner units and outer units are in perfect scaled alignment, contributing to system-wide magnetic coupling. Let's see. Now, when you look at the now this is essentially the wire that goes into the coil designs. And here I don't have the dielectric insulator in between this, so you can see the gaps in between the coil layers. Now, this is a double helix bifilar coil design. This is the input here, and then that goes down and then circles back up into the neighboring coil column. And then that one goes back into the next neighboring coil and back down, and that process continues. Now, by having this flat structure like this is what this section here explains. The high frequency skin effect inductor optimization. High frequency skin effect refers to the phenomenon where the distribution of electric current within a conductor is affected by the frequency of alternating current or sinusoidal DC current at high frequencies. During high frequency operation, the current tends to concentrate near the outer surface of the conductor, limiting the penetration into the interior. This concentration of current near the surface is known as the skin effect. In high frequency applications, this effect becomes more pronounced, leading to increased resistance and power losses. So I've designed the system to not only operate it at high frequency, but what this does for a magnetic field is increases the magnetic flux density as well with these flat surface areas, because this is an attractive force here and here. So by having these flat, we have more surface area for the magnetic flux lines to generate more magnetic flux lines. Let me put it that way. Now, also, typical coil designs are, this is the section that explains this. A typical coil winding utilize copper magnet wire that has a thin coat of clear insulation. The windings overlap without space between them. This increases heat and adds resistance to the flow of current. The heat buildup increases with each additional coil winding because the heat is forced to be absorbed and emitted by the neighboring conductor. The configuration of the macroatomic coil provides space around each conductor to effectively manage heat buildup. The copper coils are printed with nylon G glass-infused nylon filament between conductors as a high-voltage dielectric insulator, as well as providing structural support and rigidity. The integrated cooling system utilizes mineral oil is used in high-voltage transformers to control electrical arcing between conductors. Mineral oil voltage breakdown is 20 times higher than air, acting as a dielectric insulator, and will be used for Earth-based applications. For interplanetary travel and space propulsion systems, perfluorinated fluids will be used for their high dielectric strength, thermal stability, and chemical inertness that meet the insulating and cooling needs while in harsh environments of space. Now, adding to that, for space applications, we will most likely not be using copper. We're going to be using superconducting materials. A simple known superconducting material that is a lighter weight alternative to copper is aluminum. So by running aluminum and then running perfluorinated fluids as the cooling system to cryogenically cool the system, we now have a superconducting infinite range nucleus arc, which is a bit more difficult for me to project performance output until we can actually run those tests. So all of my data is based on the ampacity of copper, based on its the diameter and its ampacity based on the size of the copper itself. So let's see. Now, ARC, by the way, stands for augmenting resonant circuit. So augmenting means to expand, to make larger. Resonant is to vibrate, and circuit. So we have this essentially amplifies current. This is a current amplifier. The infinite range nucleus arc is a solid state unified power generation system. The input power and power generated are recovered simultaneously. The surplus of energy to draw from is a result of the energy contained within the system itself. No additional energy has been created. The surplus of energy has been provided by the magnetic interactions of the electromagnets and permanent magnets, positioned to maximize magnetic flux, magnetically stack and magnify the negative rate of change within the circuit, effectively transforming the stored potential energy within permanent magnets into induced EMF in the secondary coil. Again, internal energy is some of the system's kinetic and potential energies at the molecular level. We're not making energy up here. Now, the induced electromotive force in the closed circuit is equal to the negative rate of change of magnetic flux through the circuit. HVDC in sinusoidal waveform powers the electromagnets that generate an oscillating magnetic field without the use of moving parts. This is a solid state device. The oscillating magnetic field provided by the electromagnets are positioned radially in a traction configuration with permanent magnets within a non-magnetic frame. Now, I don't want to be too redundant here. Let's see. Let's talk about this. The over-unity effect and the law of energy conservation. The primary and secondary coils, along with the addition of the permanent magnets, contribute to a magnetic field that induce a higher voltage and current in the secondary coil. The increase in energy output is contained within the system and supplied by the permanent magnets. The inclusion of permanent magnets to enhance the magnetic field of the electromagnets subsequently increase the induced electromotive force in the secondary coils. In accordance with the first law of thermodynamics, the law of energy conservation, internal energy is the sum of the system's kinetic and potential energies at the molecular level. The infinite range nucleus arc effectively integrates the permanent magnet's static field into power generation, releasing the stored potential energy, producing higher electrical current than input current. It is a combination of both effects working together to amplify the induced EMF in the secondary coil. Let me hit go on this. The coil configuration in the presence of permanent magnets further enhance the magnetic field, contributing to the overall increase in induced EMF. The secondary coil recovers the input power and power generated simultaneously. A self-contained system, the infinite and power produced on demand. The infinite range nucleus arc sends a portion of the power it generates back to itself for input power. The user interface monitors load and increases or decreases voltage input accordingly. PWM controllers, also known as pulse width modulators, function as a throttle and voltage regulator, ensuring that only the power required for use is generated. An active system that employs digitally controlled pulse width modulators for power loop feedback and voltage regulation. This allows, or this is how we eliminate batteries altogether. Power is increased or decreased as power demand requires. The system is always running regardless of load in order to sustain power to the interface and monitoring system. Now, this is a dynamic system that can be applied to all different scales of power, depending on how big we can build this to how small we can build this, really is the scale that we can target with the energy demands, relative to each application. Now, as far as the configuration of the system to apply to either direct current high voltage power transmission, which is used for intercontinental power transmission, for the very longest range power transmission, today we use actual DC, not AC, which is interesting because that was the argument initially with Edison and Tesla was, is it AC or is it DC? But at that particular point, they didn't understand how to optimize high voltage DC for long distance power transmission. But now we use DC for the very longest range travel power transmission. Now, that being said, a single system by itself wouldn't be able to do that because we still need a changing magnetic field, an oscillating magnetic field. So each system has to be run, even though it's DC, it's in sinusoidal waveform. So with both if we take two systems and we run a saw wave and we run one of them 180 degrees out of phase, and then we take the output of both of these and wire them in parallel, what ends up happening is you have a solid stream of direct current. So however much power you may need to provide to do that is the size of the system itself. But with the configuration of two systems wired specifically for HVDC power transmission, we can create a direct stream of direct current. Now, if we want to use, wait a minute, let's see. Okay, this here, now let's say that we need alternating current. Now, although I can run the system by itself with alternating current, it won't run as efficient as running it in sinusoidal DC. So to take two systems and augment them to operate as single phase AC, you can take two systems to create a single leg of alternating current. And what we have here is we have one system operating at the opposite polarity, both in sine wave, and one's 90 degrees out of phase. So again, with each of them being powered with sort of opposing sinusoidal waveforms, but then the output wired in parallel, you create a single leg of alternating current. So if you wanted to create three-phase, high-power three-phase, it would take 6 units to do that. Now, the advantage here is that you're not using switchgear to do this, because with any added device, there's additional power losses. So this, again, adds to the efficiency through the dynamics of the system itself. Let's see. Now, HVDC over alternating current. In order to induce EMF in the secondary coil, the electromagnets need to generate a changing magnetic field. The changing magnetic field is achieved by alternating the polarity as with alternating current, as well as fluctuating the intensity of the magnetic field. By oscillating the magnetic flux of the electromagnets in HVDC sinusoidal waveform, the system operates in varying degrees of magnetic coupling. The configuration of the 3 sets of 8 repeating components positioned radially attract to each other and operate in concert for system-wide wave coherence and resonant coupling. The pole positioning of the electromagnets and permanent magnets are in attraction configuration. Magnetic coupling is more powerful than magnetic repulsion due to the nature of their interactions. When 2 magnetic fields are in attraction, they align their magnetic fields in the same direction, which reinforces each other, leading to a stronger combined magnetic field between them. In contrast, when magnetic fields repel, their magnetic fields are orientated in opposite directions, which tends to weaken their overall interaction. This is one of the reasons that DC is superior to AC in this system. With AC, every cycle includes an attractive and a repulsion phase, versus DC always operating in attraction phase. Okay, now let's see. Bear with me. Okay. Now, this shows the breakdown of the power output. We have our power input, we have the induced power, and then we have the net available power. So although the total amount of power being induced in a stage 1 system is close to 630 watts, it still requires 70 watts for operation. So the net available power is going to be the induced power with the subtraction of the input power. Now, right here, I have this showing for each system operating independently. Where it gets fun is when you look at this and you have it as a stage 3 system in fractal configuration, where we have the 49 stage 1 units inside of the 7 stage 2 units and the stage 2 unit inside of the stage 3 unit. what ends up happening here is that we have, by having the control of the overall amount of current being delivered to the stage 3 system is dictated by the output of the stage 1 systems. So because these are, such low power systems, we control the input feedback power to the stage 1 systems with pulse width modulators. This is 49 times 300 watts. It's roughly 14 to 1500 watts when you look at 49 units that act as the input power for this entire system. And what's beautiful about this is that over 1 megawatts being powered, with the system only having to send back roughly 1500 watts to itself for operation, providing heavy surplus of energy to draw from. Let's see. I'll go back to this so you can see. So let me think. Patent pending infinite range nucleus ARC augmenting resonance circuit, offering solutions to challenges related to energy availability, environmental sustainability, and economic development. This is a fully autonomous solid-state power source. So that's what I have here. An active, fuel-free, zero-emission power system that eliminates the need for heavy batteries, charging time, and fuel, providing continuous energy for infinite range travel and greatly improved power-to-weight ratio and zero-emission operation. Okay. Here, let's look at this. Stage 1 systems produce 589 watts, measure 3.6 inches by 0.66 inches thick, and are suitable for a wide range of applications where a compact form factor is required. Units can be stacked to combine and increase energy output and form fit to many different applications, providing structural rigidity and power production simultaneously. The Infinite-Range Nucleus ARC can be used as an active power-generating building blocks, forming the fuselage or structure that it powers. Stage 2 systems produce 24 kilowatts, measure 25 inches by 5 inches, and are suitable for all EV types. The internal kilowatt-hour meters bill the user per kilowatt-hour. Battery replacement active power system that supplies power on demand, generating only the power that is needed. Stage 3 systems are 15 feet in diameter and less than 3 feet tall, each producing over 1 megawatt. The systems can be stacked, increasing power per square foot relative to ceiling height. For power plants and substations to service the residential, commercial, industrial sectors with unrivaled power density at 200 kilowatts per cubic meter. Replace nuclear, gas, and coal power plants. All right.
Okay.
Do we have any questions coming in?
Okay, we have some questions here, and I just posted the people who want to join us. That's the thing. It's in the comments too. So here's a question from Paul Demeter. Will you be at the conference in August and have a working prototype by then? So
I'm shooting for that.
okay.
Yep. Upon when I begin 3D printing and the outsource of the or the permanent magnets, the printing time is going to be approximately 150 hours, but the permanent magnets are going to take 6 to 8 weeks. I have to outsource them. So this will be complete within 2 months of financing.
Okay, here's Danny Jabril. What's the frequency of operation and the V range out? Is there a prototype? How is the input PW applied, and how is the feedback PW applied?
Okay, let's see.
Be at the bottom of the screen.
As far as the pulse width modulator is pulling off of the supply of the power that the system produces and sending a portion of that back to itself. Now, as far as here's some data as far as now. I'm looking back to the screen. Hold on one sec. What's the frequency that I have this set for 60 hertz at this particular point, but I've designed the system to be able to operate at a higher frequency than 60 hertz, but I ran that for my calculations.
Okay, then how is it started?
Well, there's going to have to be an initial pulse of energy. So, let's say that you're already in a built system. What I envision for something like that. So if the system if it's not already operating, then there would be like a push button sort of generator or a crank generator to generate that initial surge of current to activate the pulse width modulating system to get the current flowing, to amplify the energy, to produce energy to be able to send back to it.
Okay, and how much will one of these units cost?
Well, this is how I've broken down the pricing on this. Let's see, I have 1 second. Now, I have prices per units that are over here that I believe I will be able to get these prices lower than this. This is being conservative, and it was based on sort of low volume quantities of copper filament and nylon G. So stage 1 units would be $117 to manufacture, stage 2 $5,700, and a stage 3 with the same, relative, just applying the same math to it is close to 300K. I believe that I'll be able to get these numbers down.
Okay, well, I think that's about it. I don't see more comments coming on. I'd like to thank you for being on here, and hopefully by the conference you'd have one of these built and fully functional. This is a smaller one anyway, and
That's the goal. Thank you. Yes. And thank you for having me, Steve. I appreciate you and everything that you do. Thank you.
I'd like to remind everyone again, go up to our website, check out the Test and Tech channel. Be sure to join if possible, at least subscribe because subscription is free. And here's a question for you. What is required for MRP?
MRP, what are we talking about?
Oh man, I can't think off the top of my head. What's required for MRP? MVP.
MVP?
Yeah.
What is MVP?
Most viable product. Okay, that's
Well, I was going to say most valuable player. I'm sorry. What's the question?
okay. What's required for the minimum viable product? I guess how much it's going to cost to, or what is your minimum viable product? How much is it going to cost? I would imagine.
Are you saying for prototyping or for manufacturing?
Yeah, I have no idea. What funding for MVP? Okay, how much you need to make the minimum viable product? I mean,
oh well. So for the prototype that I'm targeting is a stage 2 system, and the reason being is that the minimum feature sizes with the current available 3D printers have limitations. So with a stage 2 unit and the 3D printer that needs to be purchased for this, we're looking at roughly 50K in parts.
okay, then what is the output current and voltage?
We have, for the stage 2 system that I was just speaking of, that is, let's see. The amperage is 94.4 amps, running at 60 hertz at 110 volts.
Okay. So anyway, getting back to things. Just reminding everyone again, be sure to sign up for the conference August 7th to 11th. It's going to be at the Crown Plaza. We'll be putting out more information later on this week. We hope to have a preliminary program guide out. We have a program online right now. It's just missing a couple people. I just need to add them on this week. So keep involved there. Sign up now. You get 30% discount. And I'll see y'all guys next week. Same time, 6 p.m. And thank you for all coming. And
Thank you, everyone.
And thank you for being here, Mr. West.
Thank you, Steve.